guys, I'm Sue from Carnegie Mellon University. I couldn't wear this today because it was so hot outside, but I will be a senior at Carnegie Mellon studying global studies, and I'm working with my partner, Hyunju.
Hi, I'm Hyunju, and I major in mechanical and biomedical engineering at Carnegie Mellon.
And we will be talking about energy! So before we begin, I just had a few questions for you. What is energy? Do you know anything about energy? Or do you know any examples of energy? Okay, well, before we begin, I would like you to pause this video, exit, and take a pre-test on what you know about energy. This isn't like a harsh test or anything. It's just to see what you yourself know and to like review maybe if you know anything. If you don't, that's also really fine because we're here to teach you. And it's also for us to see what you know and what you've learned after everything, because for wrap up we'll be taking another post test. But just pause this video, exit, take the test, and come back. See you then! So when we talk about energy, there are going to be different sections that we will be discussing, and we split it into 8 videos. So the first video is the one you're watching currently. It's the introduction and the vocabulary. Later, I'll be mentioning the vocab activities that we have planned for you. And throughout each of these 8 videos, we'll be constantly repeating the terms so you engrave it in your head. That way, you'll be able to learn the terms and the subject of energy. The second video is going to be done by my partner that said hello previously. Hyunju is going to be talking about the different forms of energy. I hope you didn't think that we only had one form of energy. There are many various forms of energy. For example, mechanical energy, chemical energy, elastic energy. Did you think about these types of energy? Well, Hyunju will be talking about it further in depth. Hyunju will be doing the third activity, which is the scavenger hunt. And she's asking you to take what you learned in section 2 and applying it to section 3. So you'll be going outside and Hyunju will talk about it more. I don't want to ruin all the fun, but I hope you watch video 3. Video 4 is going to be the pendulum painting. I want you guys to create and be artistic with the pendulum painting, which will demonstrate kinetic and gravitational potential energy. And after you do that activity, Hyunju will be talking about it more in section 5. So like I mentioned, this talks about kinetic and gravitational potential energy and demonstrates it, right? By creating art, you will actually see what happens with energy and energy transfer, as well as learning about it with Hyunju in section 5. And she will be talking about like calculations and how to measure kinetic and potential energy. Did you know how to measure kinetic and potential energy before watching section 5? Probably not, right? And number 6, we can't talk about energy without collision. Collision is like, for example, when 2 balls hit each other, what is going to happen, right? There's a transfer of energy. And Hyunju also talks about transfer of energy, but I will also be discussing it in video 6 with collision. 7 is pinwheel creation, as well as the other activity, if you want to do it, a roller coaster creation. This will also show kinetic and potential energy that we talk about in section 4 and 5, but you get to do this activity. And then section 8, we're gonna wrap up all these sections of energy. We talked about what the different forms of energy, going outside, scavenger hunt, right? Kinetic and potential energy, which are really important. Collision, transfer of energy, pinwheel, roller coaster, pendulum painting creation, right? This is gonna be such a fun series, so I hope you stay in tune and complete all of this. Now we have a crossword puzzle that is highly recommended, and then a word search if you have extra time. The crossword puzzle handout should have a list of vocab terms. The vocab terms are commonly used when discussing the topic of energy, and the more you know these terms and the more you take it into heart, the better you'll understand energy. So please go take that or finish it, and we'll discuss it. We'll discuss examples of energy, and it'll be a good time, right? See you guys soon. Was the crossword puzzle fun and exciting? Was the word search good? Okay, now we will be discussing the answers as well as discussing examples and what the terms are. So this is the energy crossword puzzle answer sheet. We'll go one by one, review the answers, and we'll go further and explanation a bit later. In a different video, Hyunju, my partner, will explain more examples and math problems to understand what these type of energies are. But for now, let's just review the answers and see what you might know of each one. Let's start with across. Number 2 was the motion of waves, electrons, atoms, molecules, substances, and objects. So what did you guys put? The answer is kinetic energy. Number 5, the energy which is possessed by an object due to its motion or its stored energy of position. It can be either kinetic or potential energy. The answer is mechanical energy. Number 7 is the ability to do work. A hint is that this is what we're learning about in this series. The answer is energy. Number 8 is the resistance of motion when one object rubs against another. Anytime two objects rub against each other. This is friction. Number 9 is the energy an object has because of the movement of its molecules, and heat can be transferred from one object to another object. It is also called thermal energy. The answer is heat energy. That was 5 answers. Did you guys get some of them correct or all of them correct? Okay, good job. The other section is down. So down 1 is energy that is stored because of an object's position or height above the Earth's surface. If it involves the object's position or height above the Earth's surface, it involves gravity. So this is gravitational energy. Number 3, it is the energy that is stored in the bonds between atoms and molecules. The answer is chemical energy. Number 4, stored energy and the energy of position. This is potential energy. So energy is a wide range of many things. And in this wide range, there's 2 types of energy, mainly kinetic and potential energy. So we'll be further discussing that in a few minutes. Number 6 is stored when materials stretch or compress. Examples include rubber bands and slingshots. Have you ever stretched a rubber band or thrown something with a slingshot? Well, you used elastic energy. Now, those were all the answers. I hope you got some of them correct, maybe all of them. If not, it's okay. We'll just learn and we'll take our time to understand these different types of energy. Now, let's go over the energy word search. Atoms, conservation, friction, kinetic, nature, potential, work, chemical, elastic, gravitational, mechanical, pendulum, rollercoaster, collision, energy, heat, motion, pinwheel, and finally, stretch. Now that we've finished the energy crossword puzzle as well as the energy word search, I hope you were able to retain some of the information that you've received from the activity. Let's review some of the vocab words. Energy is the ability to do work. Without energy, we would not be able to do a lot of things. For example, cars, boats, and bicycles would not be able to move. We wouldn't be able to cook our food on stoves or ovens. The lights in our house wouldn't be able to turn on. All of these things wouldn't function without energy. There's also kinetic and potential energy that I've mentioned earlier. Kinetic energy is the motion of waves, electrons, atoms, molecules, substances, and objects. On the other hand, potential energy is stored energy and the energy of position. Both forms of energy will be further explained in the next few videos. Just know that there are many forms of energy that exist, but they fall into two basic categories, kinetic and potential energy. So this is just a side note. For the first section, we talked about a lot of things because a lot of these terms have come up in the word search as well as the crossword puzzle. But in the next few videos, we'll be constantly repeating these terms and giving you more information and more facts about like potential kinetic energy or just energy or the different forms of energy like in the next video. And that's for you to be able to engrave it into your head and take it into heart, the information that you learned. So if we're repeating things, I hope that you'll remember it and it won't seem like new information. The more we repeat things to you, the more you'll be able to understand. So that's the point of us repeating things. Even though I talked about potential and kinetic energy, for example, like you don't really know what it is, right? It just shows you that like when it's energy in or on the floor level, kinetic energy is the most, and then it goes energy in, potential energy, energy out. Even if you see this picture, do you really understand it? Not really. So when Hyunju explains it, I hope you'll be able to get it and further understand what it's going to be about. Before we end the lesson for today, can you answer these questions before we end? What is energy? The answer is energy is the ability to do work. The next question is, what are the two basic categories of energy? The answer is, it is kinetic energy and potential energy. Third question, what is kinetic energy? Kinetic energy is the motion of waves, electrons, atoms, molecules, substances, and objects. The last question is, what is potential energy? Potential energy is stored energy and the energy of position. Lastly, I would like to thank you for joining us in the first video of the energy module, and thank you to the Leonard Gelfand Center for allowing this to be possible. I hope we see you in the second video. See you soon!
Hello everyone! My name is Hyunju, and I study mechanical and biomedical engineering at Carnegie Mellon University. Today, I'll be sharing with you some of the different types of energy that exist in our world today. Before I begin, what are one or two energy-related words or terms that you learned in the previous section with Sue? Well, that's awesome! Since you already have a head start, why don't we just get started? Okay, so as you just learned in the previous section, energy is the ability to do work. But what else do we know about energy? Can you name a few examples of energy, or perhaps name different types of energy? Well, that's great! Whether it's jumping on your trampoline, changing the batteries in your remote control, or eating an apple so that you can have more fuel to do your homework or help your parents around the house, these are all different types of energy. These types of energy can be classified as mechanical, chemical, thermal, sound, light, nuclear, and the list goes on. Now, I know these are difficult words that you probably may not have heard of, and if you have, that's wonderful too, but bear with me, please. We'll walk through some of these terms and even go through a few examples of each. Mechanical energy describes the energy of an object due to its position or motion, or both. So for example, this man who is pushing on this heavy rock is using mechanical energy to move the rock. Chemical energy is the energy released when there is a chemical reaction. For example, when plants go through photosynthesis to convert sunlight and water into sugars called glucose, they're using chemical energy. Thermal energy, also known as heat, is produced when there is a rise in temperature and things start getting hot. For example, we can get thermal energy from the heat of the sun. Sound energy is produced when an object vibrates. For example, when you play the guitar and the strings vibrate, you get sound energy and you hear the sound. Electrical energy is a form of energy that you get from the flow of electric charge. Electrical energy can be found on the ceiling of every home. If you've ever turned on the light before, you have used electrical energy. So in the next two sections of this lesson plan, we will focus on mechanical energy. Mechanical energy comes in two types, kinetic and potential. When you first learn physics in middle school or high school, you will first learn about kinetic and potential energy. Kinetic energy is the energy that an object has when it is in motion. So think about a baseball that's flying across the field at 60 miles per hour. It has a lot of kinetic energy. Potential energy is the energy that is stored in an object due to its position. In this lesson, we'll focus on gravitational potential energy, which is the energy stored in an object due to its height above the ground. So think about an apple sitting high up in a tree versus an apple that has already fallen and is on the ground. The apple in the tree is much higher up, and so it has more potential energy. So now that you have a better idea of what the different types and examples of energy are, I want to share something very important with you. There's a rule in science, also known as a scientific law, that energy cannot be created or destroyed. Can anyone guess what this law might be called? If you said the law of conservation of energy, you are correct. And if you said something else, don't worry. After today's lesson, you won't forget it. The law of conservation of energy states that while energy cannot be created or destroyed, it simply is transferred from one system to another and changes from one type of energy into another. Now, something important to consider here is that this is true for a closed system. You might ask, what is a closed system? Well, great question. Think about a closed system as a box that contains only the objects you're interested in studying. For example, if you want to study how much energy is in your car, your box would contain only your car, which includes the engine, gas, tank, brakes, wheels, and other parts. This box that contains your car and all of its parts is now your system, and nothing can be left out or added when you are measuring the energy in your car. If you were interested in studying the energy of a bigger system, such as the Earth, your box would contain the Earth and all of the people, trees, plants, animals, cars, and other objects inside the Earth. Now you have a much bigger system, but you still cannot add or subtract any other object or person from your system. For example, if you see that the Earth is your system, you cannot include the planet Venus in your energy calculations because Venus is outside of the system. Now, if you're like me and you love asking questions, you might ask how we know that the law of conservation of energy is true. Since energy is invisible, how can we prove that energy is not created or destroyed? Well, excellent question. Many years ago, there were some very famous scientists who discovered this phenomenon without even trying to. Julius Robert Mayer was a German physician, chemist, and physicist, and he was one of the first people who stated the conservation of energy. He stated that energy cannot be created nor destroyed, and is transferred from one type to another. William Rankine and James Joule are also two famous scientists who contributed heavily to the field of energy research. Well, isn't that interesting? Actually, there are many scientists who continue to study energy. In fact, at my school, Carnegie Mellon University, we have a whole group of professors and students who study energy. Professor Jay App studies the reliability of the electric power grid and how we can use renewable and more environmental friendly sources for electric power. He is also involved in solar radiation research. A fun fact about Professor Jay Apt is that he's also an astronaut. How cool is that? Professor Jared L. Cohen works on analyzing water resource systems and environment and energy systems. He also works with policymakers to make our world more environmentally friendly and sustainable. Professor Katie Whitefoot works on creating sustainable practices for transportation systems and also works on policies for improved engineering systems. Professor Ding Zhao works on robotics and autonomous driving projects while incorporating energy efficiency into these projects. Wow, would you look at that? We're almost at the end of our lesson. Time flies when you're learning and having fun. So, to wrap up section 2 of the energy lesson plan, remember there are different types of energy. Energy cannot be created or destroyed, also known as the law of conservation of energy, and there is still much work to be done in the field of energy. I want to thank the Leonard Gelfand Center for Service Learning and Outreach for providing the necessary tools and resources and help in designing this lesson plan. And I also want to personally thank you for your time and undivided attention. Make sure to tune into the next section where we have a fun activity planned for you all. Bye!
Hi everyone, it's Hyunju here again. I hope you enjoyed the previous video with my brief introduction and description of different energy types and the types of research related to energy that goes on at Carnegie Mellon University. Okay, so today I have a really fun activity planned for you all. You'll be going on a nature walk outside. Now, whether it's to the park or down the street or to the beach, you can go wherever you want. I just want you to be on the lookout for different types of energy. So the different types of energy I want you to be on the lookout for are one example of chemical energy, one example of mechanical energy, one example of light energy, one example of electrical energy, one example of sound energy, one example of elastic energy, one example of solar or wind energy, one example of thermal or heat energy, and one example of an energy of your choice. If you can find more, that's great.
For example, I found an example of light energy and chemical energy in my house. Look at this plant. It absorbs the sunlight, which is light energy, and uses the energy to convert the water and carbon dioxide in the air into sugars. The plant uses these sugars as energy, just like you and I eat food for energy. With these sugars, the plants can continue to grow. So that's one example of both light and chemical energy. But when you're on your scavenger hunt, I want you to find one different example for each type of energy.
As you go on your scavenger hunt, I want you to read these instructions carefully and fill out the bingo worksheet on the second page. And if you run out of space or you find more than one example, you can always use the blank space on the back of the page. Now remember, you don't have to stay in one place. In fact, you can start in your own home and go outside if you can't find enough examples in your own house. Now before we begin, does anyone remember what energy is? If you said it's the ability to do work, you are correct. Wonderful. And if you didn't remember, that's okay. Just remember to go back to video 1 and video 2 so you can get that review before you go outside. So once you find your example of each type of energy, I want you to write down the example in the box or draw a picture of it. Now remember, you need supervision from an adult if you're going outside. If you don't have an adult to supervise you, that's perfectly okay. You can start in your own home and find plenty of examples of energy. Most importantly, remember to have fun. Now, I'm gonna grab my sunglasses and my keys, and I'll be on my walk too. I'll see you outside!
Hi guys, I'm doing the scavenger hunt activity as well, and I think I found an example of energy. Like the sun? The sun was a type of energy, right? Was it chemical energy? Was it electrical energy? Thermal energy, right? Okay, I'm gonna go down and see what other examples of energy. So my mom has a garden here, and I'm pretty sure Hyunju said that plants were a type of energy, right? Or showed an example of energy. Do you remember what it was? And I found, do you see this? A bird feeder. A bird feeder is hanging, and what else hangs? Like sometimes a yo-yo, if it's like swinging. Pendulums hang, right? Does energy apply to pendulums? I better go inside to find out. Guys, come with me. Hey guys, it's Sue again from Carnegie Mellon University. I would just like to say thank you for watching this video, and thank you Leonard Gelfand Center for allowing us to create it. Today we'll be making pendulum paintings. Do you know what a pendulum is? Well, we'll see what a pendulum is if you continue to watch this video. But first, a little warning out there for parents and students. Make sure you're not in carpeted areas, but if you are, make sure you have a lot of old cardboard, old posters, old sheets laid on the floor before you start painting. And if you want to take this activity outside, feel free to do so. Just make sure the paint is non-toxic to the environment, and make sure that you clean up after yourself and wear clothes. I'm going to be wearing an apron over this so that the paint doesn't stain your own clothes, and it's easier and better for parents. Now let's move on to the activity. The materials that you will need: around 3 feet of string, some tape, a long stick or pole, for example, a broom will do. I think I used the top of a Swiffer. 2 chairs, sheets of paper, scissors, paint, and some water. A cup, a styrofoam cup or a paper cup, but I used a water bottle as I didn't have that at home, and a smock so you don't get paint on your clothes, as well as newspapers, old sheets, old posters. I used old cardboard, and this is to prevent huge messes. Now for your steps. The first thing I did was I used a scissor to cut the water bottle in half. Because it's a bit sharp and dangerous, I would recommend asking a parent or a guardian to do this for you. The first 2 steps is a bit difficult, so if you can't do it and you think you'll get hurt, please ask a guardian or a parent. The next step is to make a hole at the bottom of the water bottle or the cup that you're using with the scissors or a needle. And cover it with tape. On each side of the cup, or each 3 sides of the cup, make a hole to loop the string through the holes. Because it's a plastic water bottle, I had to use the scissors to cut a hole, and once again, it's dangerous, so please ask someone older than you for help. Then tie the string securely on each 3 sides. The cup and string should be attached, and it should look like a mini purse. Then place the string on a pole so it hangs in the center. In between the 2 chairs or the 2 same levels, place sheets of paper or newspapers. This is for your painting. If you want to make sure that your floor doesn't get dirty, put extra newspapers on the ground beneath the sheets of paper or take this challenge outside. Lastly, get paint mixed with a bit of water or watercolor paint, water mixture, and place it in the cup that is hanging on the center of the broom. When you are ready, take off the tape and swing the cup only once to make a painting. As you can clearly see, my first try didn't go as planned, and the hole that I made wasn't big enough for the paint to drip as freely, so I tried to make another hole. This was my second or third time, but as you can see, even though I tried to add another hole or make the previous hole bigger, it just didn't work as well as I hoped. but we can still see the exchange between kinetic and gravitational potential energy in this painting. As you can see, when the bottle first started spinning, it made an outer circle and then started spinning in. And the more it slowed down, the more paint dripped in the center of the sheets of paper. My demonstration didn't turn out as exactly as planned, so I incorporated a YouTube video by Chelsea Paints of her pendulum painting. So as you can see, as it spins, it slows down and circles more near the center. As the pendulum swings back and forth, there is an exchange between kinetic and gravitational potential energy. As we saw with the pendulum painting, the cup or the pendulum is an object hanging from a certain point and swings freely with the help of a push and gravity. The force of gravity brings the pendulum down towards the earth or the ground, and once we push the pendulum, the cup, there is momentum, as well as the acceleration of gravity. Both factors in the mass of the cup with the paint contribute to why the cup swings in both directions up to a height that is equal to the position it started. The reason why the pendulum or the cup stays in motion is due to Newton's law of inertia. The law states that an object in motion will stay in motion unless acted on by an unbalanced force. Because energy can neither be created nor destroyed, there is a switch between potential and kinetic energy. Now let's observe these images. The first image shows a pendulum and shows when kinetic energy decreases and when it increases. When it's coming down towards the ground, the KE increases, and when it goes back up, the KE decreases. And then the other one on the right shows the same thing. When it comes down, the kinetic energy increases. When it goes up, the kinetic energy decreases. The next photo shows that when it's swinging, the highest point of the swing, there is no kinetic energy, and that's when there's maximum gravitational potential energy. But when it's down, it's the maximum kinetic energy and the minimum gravitational potential energy. If you would like, change the height of the cup or string, or use more force or less force when pushing the pendulum, push the cup in different directions, and test these different ways with different colored paint on the same sheets of paper to observe the differences, and have fun painting the new patterns. Lastly, thank you for your time and openness to learning more about kinetic and gravitational potential energy. I hope the activity was fun and engaging. Watch the next video to learn more about kinetic and potential energy with Hyunju. I promise it will be super fun. Bye!
Hello everyone! It's Hyunju here again. How's your day going? Well, that's great to hear. Today, I'm going to give you an academic lesson on kinetic energy and gravitational potential energy. But before we start, can someone please tell me what either kinetic energy or gravitational potential energy are? Great! So, kinetic energy is the energy that an object has when it is in motion. The faster it moves or the heavier it is, the greater its kinetic energy. Think about a baseball that's flying across the field at 60 miles per hour. Boy, does it have a lot of kinetic energy. Gravitational potential energy, on the other hand, is the energy that is stored in an object due to its position above the center of the Earth. The further it is, or higher it is above the ground, or heavier it is, the more potential energy it has. So think about an airplane flying high above the ground versus a car that's driving low on the ground. The airplane is much higher, so it has more potential energy. Now, do you remember what kinetic and potential energy are examples of? I'll give you a hint. It starts with an M. If you said mechanical energy, you are correct. Great job. Both kinetic and potential energy are examples of mechanical energy. Now keep in mind, potential energy can be converted into kinetic energy, and kinetic energy can be converted back into potential energy, according to the law of conservation of energy. So here's an example. When this ball is high up in the air but isn't moving, it has 100% potential energy and zero kinetic energy because it's high above the Earth but its speed is zero. But when it begins to move, it converts some of that potential energy into kinetic energy as it grows faster and comes lower and closer to the ground. Now, this is what we mean by transformation or the conversion of energy. Here's another fun demonstration video on how kinetic and potential energy are related. Now that we talked a little bit more about kinetic and potential energy, let's tie it back to what we did in the previous section with the ping pendulum. When did you see an example of kinetic energy? Great! And when did you see an example of potential energy in your pendulum?
So as Sue mentioned, your painting pendulum has the highest amount of kinetic energy when it's moving the fastest. So that's probably at its lowest point and closest to the ground. But your painting pendulum had the highest amount of gravitational potential energy when it was highest above the ground.
So now let's move on to how we can measure energy. There are different instruments to measure these different types of energy. For example, you can use an electric meter to measure electrical energy, or you can use a decibel meter to measure sound levels and sound energy. In fact, you can also measure how much energy is inside of the food that you eat. If you have any packaged food inside your refrigerator or cupboards, like packaged cereal, yogurt, milk, or bread, you will see that it has a section for nutritional information. Next to or below where you see the word calories, you will see a number like 100, 20, or 250. This number tells you how much energy you can gain from eating or drinking that food or drink. But this requires a special set of instruments, so we can't measure it on our own. The next time you eat something, I want to encourage you to take a look at the nutrition label so that you know how much energy you're gaining from what you're eating. And now that concludes our energy lesson for today.
But before we leave here for today, I want to tell you a little preview about the next video. So in the next video, Sue will be teaching you about collision. She'll talk about what happens to the kinetic energy of two objects when they collide and hit each other like that. There'll be a fun bowling game for you as well. So make sure you tune into the next video. And thank you again for your undivided attention and your time today. Bye!
Hi guys, it's Sue again, and today we'll be talking about energy and specifically collision. But before we begin, I have a few questions for you. So, what would happen to this marker if a basketball rolled and hit it? Do you think it would stay still and the ball would just go to the side? Do you think it would fall? What do you think would happen? Well, another question is, have you gone bowling? What is the point of bowling, right? It's to knock the pins down, right? The more pins you knock down, the higher the score you get. So we'll have a few demonstrations to show collision, and we will also have a fun at-home bowling game prepared for you. The purpose of today's video is to show how an object's kinetic energy along with velocity changes after getting hit by a moving object, or if both of them are moving, how both objects' kinetic energies changes after hitting into each other. Along with that, we will be also talking about the differences between elastic and inelastic collisions. Do you guys know what it is? Well, that's a good guess. If you did get it correct, then good job, and if you didn't, then we'll move on to the discussion as well as the demonstrations to see if you actually understood what elastic and inelastic collisions were. For the first activity, we will need these materials, any two objects that can roll. As you can see, I used tennis balls, an apple, and a balloon. This could also include marbles, a basketball, a volleyball, a tennis ball, golf ball, even a water bottle that can roll. First, we want to separate the two objects by a distance. Keep one object stationary, then hit the stationary object with the moving object and observe what happens to both objects. What do you think is going to happen? What happened, and was your prediction correct? The first activity included two tennis balls. They were objects of the same size and the same weight. But what if we did two objects with different weights? So I have the balloon and the tennis ball here. and I'm going to keep the balloon stationary and hit it with a tennis ball. What do you think will happen? What happened, and was your prediction correct? Now, let's use an apple and a tennis ball. The apple is of heavier weight, and the tennis ball is a lot lighter. The tennis ball is lighter because it's hollow inside, but the apple isn't hollow. What do you think will happen? When the tennis ball hit the balloon easily was tossed away. But the apple, on the other hand, did not move very much. It's because the apple was of heavier weight. What happens when both tennis balls are moving towards each other? None of them are stationary. What do you think will happen? Was your prediction correct? Hi guys, do you remember in video 2 with Hyunju, she talks about the law of conservation, right? It talks about how energy can't be created or destroyed. So we see the transfer of energy in collision. Do you know where we see it? Let's say this marker, right, is stationary and a ball rolls and hits it, right? The marker was stationary, it did not move, but once the ball hit it, it moved and fell, right? There was an example of transfer of energy. So what is the law of conservation? That's right. If you said the law of conservation is that energy can't be created nor destroyed, then you're correct. So now let's talk about the relationship between kinetic energy and velocity. So as you saw in the demonstrations, kinetic energy is involved when the objects were in motion. So when we saw the experiment with the 2 rolling objects, we could see that kinetic energy was in place. And velocity is in factor because the definition of velocity is the speed of an object toward a certain direction. And we can't forget mass. Mass is the amount of matter in an object. Since the mass of the apple was greater than the mass of the tennis ball, when the tennis ball rolled and hit the apple with greater mass did not budge as much, right? Compare that to when the balloon was stationary and the tennis ball hit it. The balloon obviously had a smaller mass. The balloon obviously had a smaller mass than the tennis ball, which hit it and the balloon bounced off, right? So compare the balloon with the apple. The apple didn't budge while the balloon did. With the demonstrations, I wasn't able to clearly show the change in velocity with the objects. So the definition of velocity, once again, is the speed of an object toward a certain direction. So what if the speed of the tennis ball was a lot faster? What do you think would happen? So when doing the activity, try to test the rolling objects at a greater speed towards the stationary objects or both moving objects toward each other and see if your prediction is right. Another activity that we're going to do is home bowling. We will be creating an at-home bowling alley. The materials needed for this is 10 empty plastic water bottles, soda cans, beverage bottles, etc., and any ball the size of a tennis ball or larger. Make sure the water bottles, soda cans, beverage bottles are empty and clean so there are no spills or messes. The bottles should also be aluminum or plastic, not glass. Make sure that the bottles cannot break. With the 10 bottles, line them up as you would do in bowling. 4 in the back, 3 in front of the 4 bottles, 2 in front of the 3, and 1 in front of the 2 bottles. It should look like a triangle from a bird's eye view. Next, move 6 to 7 feet away from the bottles and try to knock them down with the ball. If you want, play a bowling game with your family members and see who knocks down the most pins. Because I'm in a smaller space, I couldn't move 6 to 7 feet away, so you could just do it close to see what collision is. And that's a strike. Now, after you're done playing your bowling game, I would like you to pause this current video and move over to the YouTube clip provided for you. This YouTube video will show you how there is a transfer of energy when a collision happens. Now let's talk about inelastic collisions. As you can see this GIF of an inelastic collision, it's quite different from elastic collisions. This is what happens when two objects stick together. So we were able to see demonstrations of elastic and inelastic collisions. We demonstrated and made an at-home bowling game or tested with different balls of elastic collisions. Do you know what they were? And we saw a GIF of an inelastic collision. So elastic collisions are when two objects move in two different directions at different speeds. Inelastic collisions are when two objects move together at the same speed. So as you saw in the bowling game, when the pins were knocked down, each individual pin were hitting each other and then they all went different directions. So that was an example of elastic collision. But in the GIF, the train, when it hit together, it moved together at the same speed. That was an example of inelastic collision. I hope the review was very helpful for you to understand collisions, and I hope we see you in the next video. We'll be making pinwheels as well as roller coasters. Thank you for your time again. See you in the next video. Hi guys, it's Sue again, but before we talk about pinwheel creations and energy conversion, I'm gonna ask you a few questions about the previous video. So we talked about collision. Collision was talking about the transfer of energy as well as velocity, kinetic energy, and mass, right? So there was energy transfer between a moving object into a stationary object. So once the moving object hit the stationary object had energy, so it was able to move. But this video, we're going to talk about energy conversion. So it's not energy transfer, but converting one type of energy into another. So pinwheels. When you think of pinwheels, what do you think of? Well, when I think of pinwheels, I think of wind turbines. Do you know what wind turbines are an example of? If you said wind energy, that's the right answer. Wind turbines use wind power, wind energy, and converts that into electricity that we are able to use. So for now, I would like you to pause this video and go to the YouTube video provided. It will be talking about how wind turbines work, and you'll see how wind energy and the conversion into electricity or electric power works. Continue the video to create a pinwheel. For your materials, you will need one sheet of paper or origami paper, whatever you prefer, and one wooden pencil with an eraser end. That way, when you stick a push pin inside, it'll go through a lot smoother. I couldn't find a push pin, so I chose a pin for like my backpack or my clothes, anything you find around the house that can stick itself into an eraser, and a pair of scissors. If you decide to use origami paper, you don't need to do these first steps, but with regular paper, please fold it into this shape and fold the rectangular piece in the back. We will be cutting the rectangular piece so that we end up with just a square for the pinwheel. Now take a pair of scissors and cut the rectangular piece off. We won't be needing it. You could draw on it, reuse it, throw it out, but recycling is preferred. Cut the piece off, and now you end up with a square. You'll see there's a folded line in the middle. and then fold it on the other side so that you'll end up with an X crease in the center of the square. Now we're going to cut on the X. Maybe leave like 1 inch or 2 inches from the center to the edge of each corner. Cut a little by little to see if you need to cut more. It's better to cut little by little than to cut too much. Then take your push pin and make a hole on the right corner of each triangular folded and cut area. And do it from the back. Now that you've made 4 holes in total on each right side of the triangular shapes, make sure you collect it. But in this video, I didn't cut the slips far enough, so I'm going to cut the lines a bit more so that it's easier for me to shape the pinwheel. After making sure you cut the slips far enough to be able to compile the pieces together, use push pin and place it in all the 4 holes of each right corner, and then make a hole in the center of the square and push it through. Now take your wooden pencil with the eraser. As you can see, I don't have an eraser on mine, so I found a new one. Make sure to have an eraser as it's a lot easier to put the pin inside. Now we're done. Hey guys, now that we are finished with making our pinwheels, I recommend blowing it in the creases where it catches the air the most. So if you blow it here, then it will spin faster, but if you blow it where it kind of blocks it off, it doesn't blow as well, or it doesn't spin as well. For the differentiated activity, maybe use a hairdryer and use the different speeds on the hairdryer to see if you could make the pinwheel go faster. If you guys are interested in a second activity, build a roller coaster. Building a roller coaster will show you how both potential and kinetic energy are conserved and exist in the same system. Not only that, potential energy can be converted into kinetic energy. But before we begin, please pause this video to go to this demonstration on PBS. This is to see when there is kinetic energy and when there is potential energy in a roller coaster. After you have done the PBS demonstration, pressing the play button and pause button, seeing when kinetic and potential energy are in play, continue the video for the roller coaster activity instructions. First, your materials. You'll need construction paper, cup pool noodles, literally anything that you have in your house that you can use. Be creative. You also need a marble or a toy car for it to be the passenger of the roller coaster. The directions. Number 1. Measure starting height of passenger to determine how much potential energy the passenger has, and measure starting speed. If you cannot calculate the starting speed, just know that it is 0. The marble or the toy car is not moving when it starts. Number 2, after completing the roller coaster, let the passenger go, and observe that the speed at the end of the roller coaster is higher than the starting speed, which was 0. This is to measure how much kinetic energy the passenger has. Make sure to have fun. Please pause this video to create your roller coaster. Every roller coaster will look different. It might look like this or this. or this. As I wasn't able to show you the demonstration myself, I included a video by Andrew Gatt from YouTube. He used paper, tape, scissors, and a few marbles to demonstrate what I was talking about, kinetic energy and potential energy. In the beginning, the velocity was 0 as it wasn't moving. Then when he let go of the marble, it sped up and it went down due to gravity, as well as the exchange between potential and kinetic energy. And then if you see the marbles that already landed on the ground, they weren't moving. So velocity went back to 0. So it went from 0 to a greater velocity, then back to 0. Remember that kinetic energy is the motion of waves, electrons, atoms, molecules, substances, and objects. And potential energy is stored energy and the energy of position. We were able to see kinetic energy when the pinwheel was moving due to us blowing air on it. Both potential and kinetic energy were seen in the roller coaster. We were able to see it especially in the PBS demonstration. I hope you had fun building the pinwheel and the roller coaster. I know I did. And I hope you remember a lot of the things that we, taught you in the few videos of the energy module, because in the next video, we're going to have a post-test. So I hope you remember things. So what did we talk about? We had some vocab words. We had the different forms of energy, kinetic potential energy, collision, transfer of energy. I know I remember it. I hope you do too. And I hope you take the activities and the lessons learned from it and try to connect it, because, the more you connect it to real life examples like the scavenger hunt, the more or the easier it is to remember it. So good luck on the post test, and I hope to see you in Hyunju's video.
Hello everyone! It's Hyunju here again. How's it going? Well, I hope you enjoyed these past 7 sections on energy that Sue and I shared with you. I know we had a blast making these modules for you and sharing them with you as well. So I'm curious, what's your favorite section? Wait, really? My personal favorite was the nature walk outside. I love seeing how the science that we learn in the classroom affects the world around me. So to wrap up our physics lesson plan, I want to emphasize that energy is so important. In fact, without energy, none of us would be here. I hope that you learned something new about energy in this lesson. Remember, energy is all around us. Yes, there's energy you can get from eating a banana, but there's also energy in your car, and there's also energy in the water that you use to brush your teeth. One really important lesson to consider is that some types of energy are more harmful to the environment than others. For example, you may have heard about fossil fuels. These are coal, oil, and natural gas. And yes, this includes the oil that goes into your car. These fuels, when they are burned, create carbon dioxide emissions, which are very harmful to the environment. On the other hand, renewable resources like solar energy, which is energy we get from the sun, or wind-powered energy, are much more friendly to the earth. These energy sources do not create these harmful carbon dioxide gas emissions, and thus they're not harmful. There's a lot of research being done today on how we can make more friendly sources of energy. In fact, many professors at Carnegie Mellon, including the ones we learned from Section 2, are working on how to do this today. So if you're interested in physics and energy, you might want to consider joining these professors to find different and more friendly sources of energy.
Before we conclude today's video, Sue and I would love to hear what you think about this energy lesson plan. Were any of the activities a lot of fun? Were any lessons or activities too difficult? What was your favorite activity? Was there an activity that you didn't like as much? Whoa. Before you start giving me all of your responses, I've included a link here to a post-test where you can answer all of these questions and give us any more comments. We want to get your feedback so that we can improve these videos for future students. After you fill out the post-test, make sure you click Submit so that we can see your responses. Don't worry, they're anonymous, so we won't see your names. So why don't you pause the video here and type in this link into your internet search bar to fill out the post-test. Awesome, so thanks for taking the time to do that. As I close, I would like to thank the Leonard Gelfand Center for Service Learning and Outreach for providing all of the help and necessary resources for making these videos. I would also like to thank my partner Sue, with whom I had such a great time making all of these videos for you guys. Now that you know a little bit more about energy, hopefully you're interested in learning more physics. And who knows, maybe you'll study physics in college and become an astrophysicist. Before we close today, remember that energy is all around us, and there are so many different forms and types of energy in this world. Now, if you enjoyed our videos on energy, the Leonard Gelfand Center has plenty of other videos just like these on other interesting topics as well. So, make sure to tune into different lesson plans that other students have prepared for you as well. I want to thank you for all the time and undivided attention you gave us as we presented energy to you. I hope to see you around. Bye!